Welcome to Easy Driver, the most reliable source of automotive information on YouTube. Please like, share, comment and subscribe. Imagine a world where your electric vehicle charges itself as you drive. It sounds like something from a science fiction movie, but this isn't a distant fantasy. Wireless charging roads for EVs represent a major leap forward, promising to change how we think about powering our cars. Right now, we're on the cusp of this exciting change. By 2026, we expect to see more of these innovative road systems emerge, moving us away from traditional plug-in charging. This new approach allows vehicles to charge dynamically, right on the go, making range anxiety a thing of the past for many drivers. How wireless charging roads work, the technology behind the magic. Underneath our ambitious vision for EV charging roads lies a sophisticated blend of physics and engineering. It's not magic, but rather a carefully designed system that transfers energy wirelessly right to your vehicle. This technology depends on principles that have been around for over a century, now refined for modern transportation. We're talking about dynamic charging, where your car powers up as it moves along, making every mile a charging opportunity. Inductive charging explained, coils, frequency, and power transfer. Inductive charging at its core relies on electromagnetic induction, a principle discovered by Michael Faraday. Think of it like this: electricity flowing through a coil creates a magnetic field. If you bring another coil into that field, the changing magnetic field will create an electric current in the second coil. This is how energy jumps from one coil to another without any physical contact. In the context of wireless charging roads, this works with ground coils. These are embedded beneath the road surface. When electricity flows through them, they generate an oscillating magnetic field. Receiving coils. Located on the undercarriage of the electric vehicle, these coils pick up the magnetic field from the road. The secret to efficient energy transfer, especially over a slight distance, lies in magnetic resonance. Imagine two tuning forks vibrating at the exact same frequency. If you strike one, the other will start to vibrate too, even if it's not touched. Similarly, when the ground coils and receiving coils are tuned to resonate at the same frequency, they can transfer power with high efficiency. For these systems, engineers often use frequencies in the kilohertz (kHz) range. This allows for effective power transfer over air gaps, even with typical vehicle ground clearance. The power levels involved can be substantial, often in the range of kilowatts (kW), similar to fast charging stations. To manage this, the system uses essential components. Inverters convert the direct current, DC, from the grid into the alternating current, AC, needed to power the ground coils and generate the magnetic field. Rectifiers. On the vehicle side, these convert the AC power received back into DC, which then charges the EV's battery. This whole process ensures that a significant portion of the electricity moves from the road to your car's battery, keeping losses minimal. Smart sensing and communication, ensuring safety and efficiency. Wireless charging roads are not just about power transfer, they also involve intelligent systems for safety and optimal operation. Imagine a road constantly radiating energy, whether a car is present or not. That would be a huge waste of power and potentially unsafe. This is where smart sensing and communication come into play. Modern systems use advanced sensors and communication protocols to create an intelligent charging environment. Vehicle detection. Sensors in the road detect when an EV is present and properly positioned over the charging coils. This prevents the system from wasting energy by charging an empty road. Alignment guidance. The system can guide the driver or an autonomous vehicle to ensure optimal alignment over the charging coils. Better alignment means better energy transfer efficiency. Communication protocols. The road infrastructure and the EV constantly communicate. This digital handshake confirms the vehicle's presence, its charging needs, and starts or stops the power flow accordingly. Think of it as a brief conversation between the road and your car. Safety is paramount, and these smart systems include several features. Foreign object detection, FOD, sensors can detect if there are objects other than the vehicle's receiving coil on the charging pad. This prevents heating of metal objects, like cans or coins, that could be left on the road, which could be a fire hazard. Electromagnetic field, EMF, management. The system carefully controls the magnetic fields. It ensures that the fields are contained and do not extend beyond the immediate area of the vehicle being charged. This protects passengers, pedestrians, and nearby electronics from unnecessary electromagnetic exposure. Power regulation. Dynamic systems can adjust the power output based on vehicle speed, battery state, and system load. This fine-tuning ensures efficient charging without overloading the system or the vehicle's battery. These intelligent features make wireless charging roads not only effective but also a reliable and safe solution for future electric vehicle infrastructure. Current pilot projects and progress towards 2026. As we approach 2026, the vision of wireless charging roads is quickly becoming a tangible reality, moving from a futuristic concept to operational pilot projects around the globe. These trials are crucial. They help us understand how inductive charging works in real-world conditions. We're learning a lot about the technology, its benefits, and the challenges it presents. Global pioneers, Sweden, US, and beyond. Several nations are leading the charge. They are installing and testing wireless charging systems on public roads. Let's look at some key players and their unique approaches. Sweden's electric road system. Sweden is a true pioneer. They are actively implementing dynamic wireless charging solutions. One notable project involves Electrian, an Israeli company. They are testing a 1.6-kilometer stretch of public road on the island of Gotland. This system charges an electric bus and a heavy truck dynamically. Their goal is to create a complete electric road system for commercial vehicles. Electrian uses coils buried shallowly under the asphalt. These coils activate only when an equipped vehicle passes over them. This approach aims to make long-haul electric transport more feasible. It reduces the need for large, heavy batteries. United States Indiana Project. The United States is also making significant strides. Indiana, in partnership with Purdue University, is developing the Innovation Bridge. This project includes a quarter-mile section of highway south of Indianapolis. It uses a different magnetic field-based technology. Their initial tests in 2023 involved wireless charging for heavy-duty electric trucks. The Purdue team is focusing on durability and high power transfer. This project aims to demonstrate the technology's readiness for widespread adoption. They believe it can support commercial fleets efficiently. Other international efforts. Beyond Sweden and the US, other countries are also exploring this technology. Germany has conducted tests on static wireless charging pads for taxis and buses. They aim to reduce emissions in urban areas. South Korea has operated a wireless charging bus route for several years. Their buses charge at specific stops, highlighting an early application of the technology. Italy is testing the Arena del Futuro circuit. This project involves a 1-kilometer track that dynamically charges electric vehicles. It uses a system called DWPT, Dynamic Wireless Power Transfer. This initiative focuses on passenger cars and commercial vehicles. It demonstrates continuous charging at highway speeds. Comparing these projects, we see varied strategies. Some focus on public transport and heavy vehicles, like in Sweden and Indiana. Others explore passenger car applications or static charging at stops. The underlying goal remains the same, to extend EV range and reduce charging downtime. However, the specific technologies and deployment methods differ. This shows a healthy exploration of what works best for different contexts. Overcoming challenges. Cost, scalability, and integration. While the progress is exciting, deploying wireless charging roads is not without its hurdles. These challenges include significant upfront costs, issues with scaling up, and complex integration requirements. High initial investment costs. The cost to install these systems is substantial. Embedding charging coils and associated electronics under existing roads requires extensive civil engineering work. This includes digging up roads, laying infrastructure, and repaving. These processes are expensive and time-consuming. Efforts are underway to reduce these costs. This includes developing modular systems and more efficient installation techniques. The hope is that as technology matures and production scales, costs will decrease. Scalability concerns. Scaling these pilot projects to a national or even regional level presents a massive challenge. We need standardized components and installation procedures. The sheer amount of road infrastructure requiring modernization is immense. Imagine the logistics of outfitting thousands of miles of highway. This requires a coordinated effort between governments, industry, and utility providers. Standardizing the technology will be key to making mass rollout possible. Complex integration with existing networks. Integrating wireless charging roads with our current road networks and energy grids adds another layer of complexity. Road network integration. How do these new roads coexist with non-charging sections? How will vehicles transition between them? Clear signage and navigation systems will be essential. Energy grid integration. Supplying power to thousands of miles of charging roads demands a robust and stable energy grid. This requires significant upgrades to transmission and distribution lines. It also needs smart grid technologies to manage power flow efficiently. We need to ensure the grid can handle the increased demand without becoming overloaded. This is particularly true during peak charging times. That's the foundation of wireless charging roads, technology that keeps EVs powered on the go. But what challenges and opportunities lie ahead as cities roll this out? Stay tuned for part 2. Please comment, like, share, and subscribe for more automotive information like this. Thank you for watching.